Homework 1.5, quadratic equations. I believe this is video 6. Yes. Homework due May 16th, 2020. Again, after this video, you should try questions 9 through 12 in homework 1.5. We'll get to this in a second. So let's talk about solving by completing the square. I've got 2 more equations up here which will solve both of them. Each one has an issue, but issues that we are capable of overcoming, so it's nothing to worry about too much. But I want to solidify the approach that we took before. Remember, the plan is to get something squared equals a number. If we can get to something squared equals a number on both sides, then we can just get out square roots and finish it that way. So the technique I'm going to show you is focused on transforming this equation from a standard form quadratic equation into something squared equals a number. Let's get right to it. The premise is based on getting the perfect number here that will cause it to factor into a perfect square. Chances are the number that's already there, if there is one there, is not the perfect number. So you need to move it over. So our first step in solving by completing the square is to rewrite the equation in the form x squared plus bx equals c. Basically what that's saying is you want a 1 here and you want the constant on the other side. By the way, if there's a coefficient, which I don't believe any of your homework problems will have, you would have to divide everything by it first in order to get this equal to 1. But I did show some mercy in your homework. They all start with 1, so I'll spare you that agony. But any number on the left needs to be moved to the right. Don't be thrown off by the fact that it's a c over here, and I thought it was a plus c and it becomes a minus c. All I'm saying is, don't have a number here, have it on the other side. Don't have a number here, have it on the other side. So let's subtract 1 from both sides. The second step is a lot easier than it seems, as is the third step. It says add the square of b over 2 to both sides. Now what does that mean? That means look at the number in front, cut it in half, and then square it. Remember what we did this to the 6 to turn it into the 9. We cut it in half to get 3, and then we squared that to get 9. That will always work. This is the move called completing the square. Now in your homework, I think I can check real quick. Yes, the homework problems about completing the square start out by asking you what number should you add to both sides. And to figure out the number that goes here, all you have to do is take half of the number that's currently there, which is -2, which is -4. Half of -4 is -2, and then square that. And whatever you get after you square that, in this case +4, is what you add to both sides. That process is called completing the square, because it will factor into a perfect square. Now, if you add 4 to both sides, then you'll get a new number on the right side. In this case, -1 plus 4 is 3. But the big question is what goes inside of here. Since this starts with x squared, this starts with an x. But you don't have to guess what goes here, because what will go here is what you get after the first move, the half of move. The third step says factor into x plus b over 2 squared. Well, all that really means is when you took half of the number in the middle, that's the number that's going to show up in the factor. Go back and look at the previous example. Half of 6 was 3, plus 3 was in the factor. Half of -4 is -2, -2 is in the factor. If you don't believe me, write this out twice and FOIL it, and you go, oh yeah, it works. But it's specifically how the process of creating the squared was it's specifically how the process of completing the square was discovered. All right, so half of this is -2, that's the number that goes there. You still have to square because you have to know what to add to both sides, because that'll change the right side. But at this point forward, you can just solve using square roots. So break out a square root on both sides. Don't forget the plus minus, because that's what people do. The square root cancels the square on the left, leaving x minus 2. Get the x by itself. Move the 2 over, it will become positive. I'm sorry, what I should say is add 2 to both sides of the equation, but I think everybody knows that the consequence of that is that it moves to the other side and changes signs. And now we have 2 plus or minus the square root of 3. Can't do a thing with the square root of 3, which means I can't combine these, which means I'm done. So again, completing the square is fairly predictable. Let's try one more. Now warning, this one's going to get a little bumpy, but manageable. Can you tell why this one's going to get bumpy? What's the first move? Relocate this constant, and when I move it over here, it becomes positive. Not too worried about that. But what happens next? We add the square of half of the coefficient of x to both sides. Translation. Take half of this number, square it, and add it to both sides. And the problem with that is that that number is odd. And so when I take half of it, half of 5 is 5 halves. Now if you really want to go and write 2.5, you can, but don't be scared of fractions. Half of 5 is 5 halves, and I gotta square that. Now squaring a fraction is easy, you just square both sides of it. 5 squared is 25, 2 squared is 4. So the number I have to add to both sides is 25/4. And we'll have to factor the left and combine the numbers on the right. The factoring, even though it has a fraction, is predictable. This whole process was designed to not make any decisions. Do you know what number is going to go after the x in the parentheses? Remember, it's the number that you get after the first move up here. Half of 5 is 5 halves. Since it's positive, x plus 5 halves. Under most circumstances, you would never factor involving fractions. This is the exception. But we're not done. We're not out of the woods yet. We got to add 8 and 25/4. But wait, what's the rule for adding fractions? Common denominator. 8's not a fraction unless you put it over 1, and the common denominator is 4. So the 25/4 is already over 4. 8 over 1, we can multiply both sides by 4, give us 32 over 4. And now we can just add. Common denominator is 4. 32 plus 25 is 57. 57 over 4. Manageable. We should know how to add and subtract fractions. Where were we? Oh yes, we're on the last step, which is really just saying now do something different. Now solve using square roots. So if we square root both sides, kills the square, that's predictable. So x plus 5 halves equals, don't forget the plus minus, easy to do. Now when you square root a fraction, one approach is to square root both sides of it. So let's square root the 4 and get 2. And I can't square root 57, so I'll leave it alone. Now if you're wondering, can I break it down and try to square root a piece of it? You should always ask that. But the only way you can break down 57 is into 3 times 19. Even that isn't obvious. Neither one is a square, so I can't square root either one. So I'm stuck with the square root of 57. And now I can just move the 5 halves over, and it becomes negative 5 halves, plus or minus the square root of 57 over 2, which is a perfectly acceptable answer. Because they have a common denominator, you could go ahead and combine it into one fraction and say negative 5 plus or minus the square root of 57, but the homework would accept either one. So completing the square can transform a quadratic equation from having 2x terms into 1x term, and when it does, then you can just solve it by using square roots. But it's not always pretty, either because of what happens at the end or because you start throwing in fractions where there weren't fractions. But unless we have another technique for solving quadratic equations, if it won't factor, and if it has more than one x term, this is your only approach. Unless there's another approach that gets the job done a little, I don't want to say faster, but more predictably. Oh wait, there is. Go on homework 1.5, try questions 9, 10, 11, and 12. And it just dawned on me, and I hope this wasn't a problem in previous videos, that the far right side of the screen was a little bit off the screen. So I hope that didn't cause any problems. But if there's ever an issue with a video, please just send me a text and I'll clarify things and try to make sure it's not a problem in the future.